Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT ONE. And our guest today is David Knight, CEO of Turbine. Turbine is building a Bloomberg model data sharing service for the physical world, with over 30,000 IoT data feeds from over 100 countries. In this talk, we discuss Turbine's approach to contextualizing and indexing data feeds to make them accessible for practical use. And we also explored how co-locating Turbine servers with 5G cell towers can enable edge computing, as well as the challenges of monetizing IoT data. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iotone.com. Thank you.
David, how are you?
Good. How's it going?
Very good. And yourself?
Well, there's this weird thing that happened where one time I found myself alone in a conference room with Elon Musk, and quite a long time ago. And at the time, he was talking about his vision that, he really wanted to go to Mars, but he also said that he wasn't going to go say that loudly until he proved that he could build rockets and get them up to the space station. But I noticed that once he'd done that, he had his space cred, instead of street cred, space cred. Then all of a sudden, he's on television talking about going to Mars. So he was very careful to go through steps of development, credibility, and so on until he could really talk about the big vision. So nowhere near that publicly. We're kind of doing a thing where we knew when we started Turbine, the infrastructure for what we really wanted to do wasn't there at all. We needed, 5G to be there. We needed co-located edge computing centers to be mounted at the base of 5G cell towers. We needed artificial intelligence to move along thanks to the steady progression of Moore's Law and the general acceptance of IoT. And of course, now all that is vectoring together beautifully. So here we are.
Great. Well, let's get into it. And I'll just make a note to our listeners that, let's see, we first spoke back in, I think, February 2018, and that's episode 29. So if anybody wants to kind of get some of the backstory or what Turbine looked like a couple of years ago, they can refer back to that. But obviously, a lot of progress has been made in the past couple of years. So let's start discussing. I mean, maybe a good point to start before we get into more of the technical details is just, what is the concept here? I think you actually in the analyst report have a fairly ambitious, but also fairly, well-fitting, I don't know, it's not really a slogan, but just analogy, which is this is the Bloomberg for the physical world. What is, kind of the high level concept that let's say your 30-second elevator pitch when you're just giving somebody a quick overview of what your vision is?
The overarching vision for Turbine is to become the brain, if you will, that will manage transactions between machines. And this is on the assumption that machines are going to keep getting smarter thanks to things like artificial intelligence, that they're going to be increasingly connected to ever higher speed connections thanks to 5G, and that the volume and velocity of the data that needs to be transacted between machines will radically exceed the ability of humans to stay in the loop. So if you look at, say, the evolution of how commodities are exchanged today between, as opposed to what was, back in the day when they were trading slips of paper, IoT data has not matured yet. It's really become a thing where companies act as gatekeepers, and if you want to get somebody else's data, you likely have to go through this fairly arduous process of attorneys talking to each other and grinding contract discussions. And we want to pull all that out of the loop like they have in other industries and reduce months to milliseconds where, say a self-driving car needs some data that comes from the infrastructure it's moving through, or maybe data from a drone or to a drone, or augmented reality glasses and swarming robots that are cleaning the streets, all this cool stuff that's coming. It has to happen in a highly automated fashion. And it's not enough to just say, well, we're going to use, vehicle to vehicle communications, because none of that solves the huge plethora of issues that have to do with business and legal and regulatory and money, quality of service, all those things that you have to worry about when you want to make it a real industry.
Right. I mean, you're not even really solving the communication problem, right? That's more or less been solved, or other companies are facilitating communication, but you're helping to solve this legal framework for, some sensor somewhere is outputting data. How can I gain access to that? And how can the owners of that data be monetized, or make sure that they're only sharing that data with the right stakeholders, the people that they've, how does that, so there's really like kind of a legal challenge here. So how, if I have, let's say, a set of sensors in my city and I want to somehow enable people to access this, maybe I want to monetize it. Maybe I just want to do this because the city government feels like this data should be available. But some of that data might have there might be some metadata that's maybe privacy related or somehow sensitive. So how does somebody put data on this platform and then pre-approve it, or make sure that they're comfortable in that only the right group of stakeholders will use it, and only they'll only have access to, let's say, the metadata or the anonymized data that the owner of that data set is comfortable with?
Right. Well, there's quite a few issues in there, but I'll unpack it. So you start at the very beginning, the most nascent part of this, that IoT data isn't like, say, financial data or things that are recognizable just by themselves. IoT data, with very few exceptions, is what's called time series. Time series data is literally, this is highly repetitive. It might have a time and date stamp. It'll have maybe some identifier for the device, and then there's, value, comma, and so on. The file name, if it's a file, would probably be the time and date stamp. It may not even identify the device. And then you've got knock-on effects that if it's a big stream coming at you at very high velocity, you're just getting millions of those, and there's nothing at all that gives you any context. So what generated that? Where is it? What affects its readings? Who owns it? Is that the same group that has the rights to, let you use it? And then you get into the more esoteric stuff about, policies that control who does what to whom. But way back at the beginning, you have to make this data discoverable and accessible. So we started with that, just chipping away at that problem. And what we came up with was a universal metadata construct, to use a slightly technical term. It's a metadata specification that can work in almost any industry sector, because for this stuff to be conveyed across different sectors, you can't just have one for automotive and one for electrical. You have to have one universal specification. I actually was involved with setting those standards back in the early days of email, and how things like attachments are conveyed. So I've been through it before, and you have all these stakeholders and gatekeepers that you have to convince to jump on board. We're going through that same process right now with Turbine, and it's sort of a never-ending process. Now, once you have the discovery solved, the next part is, well, how do you gain access to it? So we built this whole system that's cloud-based with APIs. It also has a web interface, which is turbine.io, if somebody wants to go look. And it makes it discoverable and accessible. And then an outer layer around that covers rights conveyance, privacy, if there's a privacy issue. I like to mention very little IoT data actually has anything to do with privacy, because it doesn't identify an individual. And it's really important to distinguish privacy, which has to do with humans, from proprietary, which tends to have to do with companies. Controlling where proprietary data goes is a really big hallmark of our system, where if I'm a car company, I can have absolute control over who sees my data, under what conditions, when. The conditions can change, and we can dynamically reconfigure those policies. And it's a big thing we've had to develop, really, to make everybody comfortable with it, but also it has a lot of benefits as you move to where this is totally automated. On the legal side, so legal bifurcates into rights management on the sort of commercial part, but then you've got the regulatory part. IoT data per se has not really been regulated at any scale yet. However, some of these blanket sort of legal fabrics like the GDPR in Europe do touch IoT data because it doesn't discriminate on what the type of data is. So we have to account for that also through policies. And then the last part is, well, what if you want to monetize your data? How do you ascribe value to something that has never been valued at scale before? And by the way, remove all these obstacles about humans calculating prices and negotiating. I mean, that's just all got to go away. So the best example that speaks to that last bit is what happened in media when we went from spinning pieces of plastic and before that tape or bigger pieces of spinning plastic to digital downloads and eventually streaming. It used to be that in every country, and especially if you wanted to use the music in, say, a movie or something like that, it just always involved these really onerous, negotiations that could even take months. The media industry had to figure out how to just normalize all of that and how it's priced just to make it happen. And without going into the details, because it's very well documented out there, they just kind of plowed through that process to where now you can just go click, it shows up on your device, everybody's happy. We realize there's a lot of interesting similarities to that part to the conveyance of data generated by machines. And we're even applying some of those principles that the media industry spent a lot of money and time working out. So if you're a city and you've been offering your data at no charge, we're going to some cities right now and saying, you could make money on your data. We know you don't know how to do it, but if we do it for you, and we'll, by the way, cover your hosting so you don't have to pay to host your IoT data anymore, everybody wins. We share the revenue. And we also know empirically, because we are the first people to collect data from infrastructure on a very large scale. We have about 35,000 data feeds now from all over the world. These are cities and counties and states and federal agencies in the US and their counterparts in many other countries. That data, they usually put up open data to meet a requirement that is, mandated. And we've learned that on average, that only about 20% of that data that they actually generate from their infrastructure ends up to be available through their data portals, mostly because of financial issues. So we're starting to go back to them and say, we've already done this nice job of beautifully contextualizing your data and indexing it, and it's on our portal. If you give us the other 80%, we do the work. The city doesn't have to do the work. And then it'll really be available to people, and increasingly we'll be able to monetize it on behalf of those cities.
I realize I gave you kind of a loaded question there, and it's resulted in a good overview of how the model works. But maybe we can return to really this basic question of what are the machine data feeds? Because sometimes I think people hear machine data feed and they think this is my vehicle, my refrigerator. I mean, those could be certainly data feeds. I was talking with somebody a couple of weeks ago, and they were, looking at how they can monetize video feeds. Say somebody installs a camera outside of a building, and all of a sudden you can understand, who, maybe there's a sale at Nike. So, okay, who is that sale attracting, and so forth. And that kind of data would be valuable to Nike, also valuable to competitors, also potentially valuable to the stock market that wants to see if a new shoe launch was successful. And there you get into more complicated privacy issues. And there's people involved, there's companies involved. But my feeling right now is that you're primarily dealing with public infrastructure. Can you kind of give us a vision for what are the different categories or types of data feeds that you're mostly working with right now? And then if you look forward, 2 years, 5 years, what different categories do you expect to onboard?
Yeah, well, you mentioned Bloomberg. We've in that respect followed what Bloomberg actually did. So there was once a guy named Michael Bloomberg, and he did struggle initially, if you go to the history of his company, to get big financial houses like the banks and so on to give him their data. I remember he's dealing with financial data. And a lot of them went off and set up their own marketplaces for their data. They were talking about people like Goldman Sachs or Standard & Poor's, for example. He realized that if he could just create a common index of publicly available financial data from all over the world, that alone would be enough to get people to pay for access because of the sheer convenience. And so that worked. And then once he used that to build a user base, he was able to turn around to the commercial companies and say, hey, I got all these users. This is where you're going to find them. And it's sort of like a critical mass thing, like the way eBay or, and so on built. So he was able to go back to them and say, well, now I have users. You need to pay attention to me. And of course, that led to the monstrous Bloomberg we have today, that has millions of users around the world. Now, in our case, with machine-generated data, it's very different in the sense that there's a very large range of use cases or applications for the data that really cover a lot of ground. And so it's really hard to just narrow it down and say, this is just for hedge funds. And if you do go talk to a hedge fund about this kind of data, by the way, you've talked to 5 guys, you'll get 10 answers because once they think about it, they'll change their answer about, well, I'd like data from ships. I'd like data from cars. So let me get to the bottom line. We decided to start very similar to Bloomberg, but with public infrastructure data because we knew we could get it and without a lot of debate. So we started working on that. And we also knew that eventually that would lead to strong partnerships with municipalities and other governmental entities that would be really valuable down the road as we move towards smart cities, smart infrastructure, autonomous vehicles, you name it. But it's been very challenging because, and it's not dissimilar to the original Bloomberg in that if I want to get, say, traffic counts from around the United States, every single city, county, state agency that collects that data requires you to set up an account. And remember, this is for free data, basically. They all present it in very different or slightly different ways. You have to normalize how you access it. Some are through APIs, some are through web portals, some are FTP servers. It's very painful. And so by normalizing all that through a common interface with a common metadata format, it just takes all the heavy lifting away. And now, for the first time, say an insurance company doing property and casualty risk analysis can say, oh, well, now I can see what's happening at all these intersections in Chicago, or I can see what's happening, and then I can compare Chicago to Dallas or London. And that's a really big deal. So where that can go, obviously, is we'll start to scoop in more and more data from those regional providers, those governmental ones. But we will also start to bring in the commercial providers like Bloomberg did once he had a critical mass as a base. And this eventually will lead to doing it faster and faster and faster to where it needs to happen right at the street level where we're actually running our software on servers installed at the base of 5G cell towers. That's really where we plan to go, to just be pretty pervasive.
So this approach of kind of standardizing how the data is structured are you basically introducing kind of a middle layer between the raw data and the end user, or are you applying a standard where the municipality would actually agree to adopt a standard and standardize how they structure their data?
Well, the latter is, dare I say it, close to impossible because there are thousands of data formats and variants, thousands. And I've seen a lot of attempts to standardize these things, and they can only try to do it in one narrow sector. So even then, you're going to have lots of these quote unquote standards covering different sectors, which is going to make it hard to move the data. So after a lot of analysis of what was out there, we decided that we shouldn't touch the data. We should create the metadata layer, do all the work in the metadata layer. But it's a layer in the sense that it's this new thing that's in parallel with the data. It is not, the data never passes through the metadata. That's why it's frankly called metadata. Well, let me give you a great example that one of our cool investors gave me, which is Netflix. So if you think about it, Netflix is doing for media what we're doing for IoT, and in a way what Bloomberg did for financial data and what Amazon does for products, or in China, Alibaba. So think about this. When you go to look and I'm going to pick a movie or a TV show to watch, you don't sort through a file folder of thousands and thousands of MPEG files that just have a name with a timestamp on them and maybe WB for Warner Brothers in the file name to give you a clue of who originated it. And then you would literally have to watch the first few minutes of every single MPEG file to figure out what it was. And you still might not even figure out what it is. So, of course, we don't do that. We go to this common portal, Netflix, and they beautifully present all the titles, and you can search on things like the actor and the name of the thing, or who's the director, or the studio, or when it came out, or how long it is, or what genre it is. And all of that is done through metadata that is generated by Netflix. And then all of that is in their common, and that's kind of their secret sauce, if you will. It's what binds it all together. So they don't touch the movie. They do all the work in the metadata layer. Actually, phone calls work the same way. There's a separate layer to the phone call called the out-of-band signaling layer where all that work is done. And it includes the money and the licensing and all of that. And same with Netflix. And it's the same with iTunes. It's the same with Bloomberg or even eBay. They all have a heavy metadata component to it that is really where the work gets done. So we're doing the same exact thing, but mapped onto the Internet of Things.
Gotcha. And then do you have this process more or less automated now, or is it more like an army of people? Every time you onboard a new data feed, you have to have somebody try to figure out where this is coming, because I suppose a lot of this, this metadata is not readily available. You have to do some sort of investigation in order to identify this. Is that correct?
Well, first of all, literally the metadata doesn't exist at all in almost every case. There really isn't any metadata standard, for the IoT. That's what we're trying to produce. So you're right, you're spot on there. We realized that just showing up with some machine learning algorithms would do nothing. So we went and talked to people at very successful companies that have started with humans and gone to AI, like Splunk and Palantir are some examples, and even the guys doing DeepMind and things like that. And they said, look, you always start with a room full of, usually young, quote unquote, cost-effective computer.
Yeah, University of Arizona, right?
Sure. Well, ours is University of Nevada.
Oh, Nevada, yeah.
And we have what I call our fleet of computer and data science majors. And what they're doing is, like those other examples, is you have to go do it manually and let a human brain figure it out. So imagine we just say, here's the traffic counters in Milwaukee, Wisconsin, and that's all you know. That's all you know. You don't know anything about the sensors or any of that stuff. So you have to go do this heavy detective work to figure it out. And over the last 2 years, as we build up to what are now these 35,000 data feeds and growing, we had to figure out, how would you do that in artificial intelligence? So you start with human intelligence. And we have developed these software tools that enable these young minds to get better and better at it. It's really interesting and sometimes fun to just kind of sit with one of them and say, how did you decide that those ozone readings, needed to fit into this category? Because nothing says that, but you decided that. And then we'll kind of notate what they've been doing, and that advises how you do it in a machine learning model. Now, we're now slowly, gradually, carefully taking this into a machine learning model, because eventually, if it's happening at warp speed, it's got to be done with full automation. And there's 4 different vectors for us. One is automated classification and contextualization of the data feeds, in the absence of much to tell you what it is. So it is it's not like categorizing files. That's pretty common. This is a bigger animal. The next one is, how do you automate the generation and enforcement of policies for the data usage and where it goes and the conditions? Right now, you can set that through our API, which is already pretty cool, but eventually you're going to change policies on the fly based on changing conditions and relationships between companies and so on. So we need to make that happen. The next is, how do you automate the pricing of the data like they do in a commodities exchange? The one thing about IoT data is it's usually just abundant. There's no scarcity. So you can't have this auction concept where, because it's scarce, you charge more. It's actually really, really complicated to ascribe value to IoT data. We have a group of 21 variables that we have to resolve to set the price of a given data feed, and that can change. So we have all these large companies, very interesting, in cities who have been talking to us lately saying, we don't know how to price our data. Can you help us? And it's been really interesting. I think we're talking to every car company, including some of the new ones that are these pure electric car makers, about that topic, for example.
And then let's say, okay, so they price their data. Would their objective be here to monetize and have a new revenue stream? Is that the primary objective? And then if so, I suppose, if I was an automotive manufacturer, I might say, okay, I'm comfortable with Wall Street using my data, for a higher level kind of analysis of industry trends, but I don't want, my direct competitor to access my data or something like this. Are these, maybe you can explain first what is their objective in putting their data on the platform, but then what are the typical more strategic challenges that arise during these conversations?
Well, the car companies are kind of unique in this regard that they, this will sound a bit, of an oversimplification, but for about 100 years, so I'm not talking about Tesla or Rivian or any of the new ones in China. This is the traditional car makers. For about 100 years, they bend sheet metal, add plastic, put it all together. They have no direct relationship with the consumer other than advertising. It's all done through dealer networks. And the big profits are in parts replacement and maintenance. So all that's going away in the era of things moving to electric, which require almost no maintenance, and eventually automation, where the individual may not even purchase the car. And so while they're dealing with these tectonic shifts, Tesla for sure is beating them all up on. They're trying to think, well, is there another way I can get revenue other than the traditional way? What about my data? The car throws off tons of data. What we're learning is they're really locked into this sort of paradigm where it's all about the purchaser of the car. And so that immediately drives a big discussion about privacy of the data. And the irony is that's probably not where the money's going to come from. We know empirically from being out there, for example, engine control units, and this is on a internal combustion engine, not electric, they actually have to capture the ambient air temperature, barometric pressure, and readings from what's called the mass airflow sensor many times per second to continually modulate the fuel-air mixture for the car. And this has to do with power, emissions, fuel mileage. And it's this sort of, they call it a magic triangle that's never resolved. You can't have everything. You have to have only one of those be important at any given moment. I want power. That means I can't have mileage or good emissions. I want good emissions. Well, then you can't have power. And this is what a car is calculating, any type of car, all the time. So they're asking, well, could that data be useful, like the barometric pressure and ambient air temperature data? Well, the answer is yes, if you start to view the vehicle as a rolling sensor package and not, so-and-so's car, then it comes down to factors like geographic density and what hours are these things on the road and all sorts of issues. That helps you calculate what that data might be worth to somebody who has nothing to do with cars at all. They don't care that it's this brand of car. They want to know what's the ambient air temperature and barometric pressure at that spot on the earth at that moment in time. So it's such a different way to look at things than what the automakers are used to, that there's been a pretty large education process. I should say it's enthusiastic. I've literally presented to anybody you can name over the last couple of years. Some are farther along in their thinking than others. The new electric guys are really interesting. Their vehicles capture an overlap like anti-lock brake and traction control activations, but they don't need to sample the barometric pressure usually because that has nothing to do with, there's no fuel-air mixture in an electric car. So you have different sensors. But the more of this you have, the more abundant it becomes in a given geography, the more valuable it is to an ever-increasing sort of range of users who would be willing to pay for that. And it would be very, very expensive for those user organizations to generate that data on their own. So it's a nice match. Somebody's developing that data for one purpose, somebody else can use it for a different purpose, dissimilar to the original intent. So they're willing to pay for that.
Yeah, I know. It's fascinating because it's such a strong value proposition, right? this tremendous resource that's being almost completely underutilized because of all these challenges that we've already discussed. One of the challenges here that is maybe particularly interesting is how do you monetize that, right? So you have some data feed coming off of a car in Nebraska, and that has, some minuscule value that's, it's positive, but it's, do you monetize do you say that access to this data feed, which is maybe all of the vehicles in a particular geographic region, costs this much per month? Or do you actually try to say every time you get a piece of data from this sensor, you pay, $0.001. And then I guess, I don't know if you're familiar with the company IoT, it's a German blockchain company, and kind of their value proposition is that you can make feeless payments between machines. So that, I don't know how viable this is today, but at least their premise is that you can make machine transactions that are really insignificant values, but high volumes without fees, which would completely destroy the business model. But what's your approach here? Is it a fee-based? Is it a kind of a transaction-based payment? Is it a feed-based payment? How do you address the challenge of payments in this very complicated environment?
Just as a point of it's a bit of a nuanced point, but we don't ever talk about payments. We talk about billing, because the first act of monetization is you have to ascribe a value, they call it, and then somebody has to be willing to pay for that. And then you generate a bill when the transaction is completed. So the actual mechanism for payment, like whether it's cryptocurrency or whatever, that's like way down the chain. As Turbine, we're very agnostic about that. It could literally be a MasterCard charge or a corporate wire up to, a rapid payment through some cryptocurrency mechanism. So the real issue, there's so many other issues to solve other than the payment part that are really big issues. So we're focusing on these immediate issues. So the first part you're talking about, we actually had to develop a multifaceted billing model. And it's because different sectors and players have different needs. And we became very sensitive to understanding, if you've ever read the Jeffrey Moore books, which are sort of like the biblical reference to the tech industry, he, crossing the chasm inside the tornado. One thing he talks about is don't just make your product or service easy to sell, make it easy to buy. And I really, really take that to heart. So to make it easy to buy, we have to kind of understand, what are companies used to paying for it and what mode? So what are the prevailing models for data conveyance? Well, there's subscriptions, which are usually what you'd kind of glibly call all you can eat. Then you've got buy the drink, if you will. I get this data feed for this many gigabytes or this many seconds or what have you, and I pay this much for that. And then there's just by the transaction, which means regardless of the size of the data or the duration, it's if you can fit it into a single transaction. And so all three of those are present in our system, and the data provider can configure them so that they, have all that control, and they can be configured on the fly through an API. So human doesn't have to be in the loop. Having said that, the part about how you value it is really complicated, and that's when I mentioned those 21 variables we've determined. An interesting thing I'll mention for people listening, what we call currency of the data, meaning is it real time or close to real time? In so many use cases that we've looked at, the recency or currency of the data doesn't matter, and in fact is a negative. So here's an example. If I'm trying to route a vehicle, you want generally real-time data. But if I want to know, say I'm doing a crop yield analysis, I need 4 years of data. I don't need to know what happened 1 millisecond ago. I need to know what happened for the last 4 years in that region. So it really, really depends on the use case, as far as what kind of data is valuable to one entity versus another.
Just to make sure that I and the listeners are kind of understanding how this works correctly. So we have a set of data providers, and then we have a set of data users. So they could be both a provider and user, but the providers are providing this data stream. And I suppose you're not coming up with set terms for how you would value their data, right? Because that would put a lot of financial risk on Turbine. So I suppose they're being compensated or they will be compensated for their data based on usage. And then the users might be using data from multiple sources. And so they don't want to be paying individually for each of those sources. So they would get like a month, just a bill. Is that kind of how this would work? That both the users would get a bill based on all of their aggregate data usage over a period of time, and the data providers would get a payment based on the usage of their data over a period of time. And then you would act as the middleman kind of orchestrating this, just so we can kind of clarify how this would work.
Like I said, we have multiple modes for the way that it's charged. It really has a lot to do with, like I said, the combination of what the data provider is used to and expects versus how a customer is used to paying for things. And because we tried really hard to conform it into one model and realized that there were too many other things for big companies to get used to try to create a whole new way that they deal with the money part. So we said, we're going to use standardized methods for that, but mapped onto this type of data. And then as we go through time, it'll get more and more and more granular in real time. But the truth is, big companies, accounting systems, meaning the back office systems that big companies use to run their businesses, are not set up at all for microtransactions. It's not, in most big companies, that's not even a concept. So despite all the hype about blockchain and cryptocurrency, the big companies really aren't set up to do that. If you see a big name in some blockchain consortium, that's usually a very experimental thing. But when you're talking about production, like what runs the company, what they expect is you send them a bill that's usually a monthly bill. Very rarely is it a smaller increment than that. And then they're going to take, 30, 60, 90, 120 days to pay you for it. That's how they work. So to conform to that, to make the product or service easy to buy, we've made sure that we can accumulate transactions and then hand them off in a batch. It could be real time, but again, we've yet to have a big company ask for that. They all want it in a batch. So back to your original question. Right now, what we announced a couple of weeks ago is that you can now pay for a subscription to Turbine, which gives you access to everything in the system. It's, to use the fun term, all you can eat. All of the data sources in the system right now come from government agencies of one type or another around the world. So Turbine, we don't have what they call a cost of goods sold for that, a COGS. What we have is the fairly complex process of finding those things, doing that work to create rich metadata around them, ingesting it into the system or writing code that links our API into theirs so that it's now available as a continuous feed, and a whole bunch of other things we have to do that cost, resources. And so we have a cost of what you'd call data acquisition, but we don't have a cost of goods sold. Once it's running in our system, it's in the system. And so we can amalgamate as many feeds as we get under the one monthly subscription fee. And then once a company decides they want to use our API to access it and not have humans do it through our web interface, then there's, this sort of volume-based pricing that comes into play. This is a very, very similar model to things like Bloomberg and other data vendors in other sectors.
Yeah, I think this subscription model, it sounds very straightforward. So it's $7.95 a month for an initial user, $195 a month for additional users. Very, very reasonable for a company that wants to test this out. The other group of stakeholders that you're more actively engaging now are companies that want to put their data onto the platform. I know that right now you're working almost entirely with public sector data. You've already mentioned that you're communicating with many automotive companies. Who would be the other categories of private sector companies that you're focusing on engaging as, let's say, the next wave of data sources on the platform?
Yeah, that's a great question. And, much like Bloomberg, the commercial data providers are going to want to be paid, right? So we have to provide some kind of a revenue sharing, which we've already defined. And as they come on board, they will. So these are going to be priced a la carte, where if, say, you have that data subscription, it's everything, all of the government agency feeds are, there's about 35,000 now. Even if we get to 1 million, it's still going to be the same basic fee. However, if a car company is on the platform, they do expect to be paid for their feed. So we have worked on this monetization format for them. And again, they can decide up front, do they want it priced by the amount of data or the frequency of access, or it could literally be this model of car, for example, in this geography. You get all the data from that model of car and that geography for this much per month. So we've already built all that into the system. And then, so knowing that, the car companies kind of showed up first, but now we're talking to absolutely fascinating the energy companies, both oil and gas as well as electricity. We're hearing from supply chain and logistics companies, these big trucking fleet operators, big companies that run container ships, oil tankers, satellite companies. I'll go back to something way early in our discussion here. Artificial intelligence is enabling visual domain information, meaning data from video cameras or still images, to be analyzed very inexpensively and quickly now. And you can say, well, that video image from a satellite has, there's 12 container ships in the Panama Canal right now. Whereas before that would be done by a human with a loop looking at big, photographs. Well, now it's just instant. You look at cool companies like Planet Labs, that's what they're doing. So now that can turn from raw visual data into essentially, data, time series, alphanumeric data streams. Now it becomes appropriate to put into our system where if you said, I need the counts of cars in parking lots of big retail stores, now that's something that can start to show up. And you're going to see, for example, augmented reality glasses, which actually are coming pretty soon, or self-driving cars. They're basically capturing what's around them, even the Microsoft HoloLens. They're capturing what they call spatial information around them. Well, it comes back in the form of data, giving you incredibly detailed 3D mapping of what's happening or what's changing in a given scene. And so instead of using it visually, that becomes data that can inform things like, hypernavigation, like say, a drone having to fly under the catenary wires for the trams down a street or something interesting like that, and the leaves of a tree could take down most drones, so you have to have this micro navigation it's a lot more sophisticated than just GPS coordinates. So believe it or not, all those applications are going to be here within 3 to 5 years. 5G will make the data move fast with low latency. So really at the very beginning of this, starting with a very fundamental marketplace concept, it eventually evolves to transaction handling between machines at a very high, volume and velocity.
You just mentioned 5G, and we discussed this very briefly earlier, that you're going to begin co-locating turbine servers with 5G cell towers. What's the advantage there? What's the kind of the proposition?
Great question. So I have to tell you that there are things in 5G that aren't present in 4G LTE or anything like that. There are fundamental things, but the public relations and marketing you hear about 5G all seems to be about getting even better video to your phone, and I don't know, for me, I think the video on my phone's pretty good already, but I don't know how much better that needs to be. But the truth is that the hallmarks of 5G are in really cool things like the ability to rapidly switch a data stream from one cell tower to the next without any dropouts, the ability to allow third parties to have their own basically segregated data streams. And the management of all that is really complicated, but it's all there. It's all in the protocols and in the switching equipment. So as the telecommunications operators start to install 5G, which will either be in the same cell tower complex or brand new ones for any number of reasons, a lot of them are going to be putting these little bunkers at the bottom. They would be the size of a bedroom, and they have a whole bunch of servers in them. And there's even some really cool startup companies that are working on this. So this is like a data center that you'd have in cloud computing, but it's sitting at the edge. It's at the cell tower. So the advantage is data can come into those servers and be processed right there and go right back out to whatever needs it without having to go all the way back to the data center where the cloud stuff is. Now, we're talking about really small increments of time, really small, But if you're trying to update the imagery in a smart windshield or augmented reality glasses, or you're trying to navigate a swarm of street cleaning robots or something like that, you'll take every slice of time you can get. So what we want to do is we put a Turbine server in there, and we can manage the transactions between all these entities. Why is that going to be important? It's because we know that each car company, they're going to want their own servers. The people making the display technology, they're going to want their own servers. The drones, their own servers. The mapping people, their own servers, and so on. For any number of corporate and proprietary reasons, they don't want to just pile into somebody's server. So these companies making these bunkers for the servers know that. They've been talking to lots of companies. And these things will hold 200 to 300 servers, each. So imagine Turbine comes along and says, we're a common information bus, and we are a trusted authority to manage the transactions going between these servers. So, for example, drones capturing data passes through us. We deal with all those issues we've mentioned here, like business issues, licensing issues, money issues, policy issues, all those things, quality assurance. And then we hand it over to the, say, the server that's generating imagery in a smart windshield. It's not realistic to think every single entity is going to have a relationship with every single other entity directly, because that would be a mathematics problem, which they call an n times n minus 1 conundrum. So this has been solved in many, many other domains by creating the equivalent of a common control and information system. Air traffic control does it for aircraft. There's a version of that for intermodal containerized shipping. Phone calls have that. We're proposing, if you will, to do that for the world of machines that need to send data back and forth.
Okay, fascinating. So if I can summarize this in language maybe simple enough for me to understand, make sure I'm clear here. You're kind of enabling all of these edge computing use cases by, right now, everybody that talks about edge computing is really talking about how to use their data on the edge, right? So they control the data, and that's all that they have access to. Now you're enabling all these edge computing use cases to use data from any source that's on the Turbine network. That's kind of good, the potential result here?
Yeah, that's a good summary. It's just a almost linear evolution of what we're doing now in the cloud. So most people talking about edge right now, they tend to be talking about what I call unidirectional data flows. So, you put an edge computer out there in the middle of somewhere where there's an oil well, and you pre-process the oil well data, and then you send it up the line over what might be an intermittent low quality connection, But we're talking about where edge really goes, which is fully bidirectional data movement between different parties. And so even if two vehicles can send a radio signal to each other, there's still got to be something around that, that says, well, that's okay to do. I can assure you, when the business people and the attorneys get involved and worry about things like liability from one car company using another car company's data, there will be a demand for what we're talking about, where you need this intelligence that is the trusted thing managing all those transactions. The best part is that in many cases, the data doesn't have to flow through our servers at all. We're just the brain that decides, who does what to whom.
Well, David, you are taking on quite the challenge here at so many levels. This is just a monumental effort, right? A coordination effort, a technical effort. I've been wondering for a while why nobody has created this, right? And I guess the answer is fairly obvious. It's extremely challenging. Can you give us just a quick vision into the next, let's say, 12 to 24 months, and particularly for companies that are listening to this and thinking, okay, how can we get involved with Turbine either as a data provider or as a data user? What is going to be feasible over the next 12 to 24 months, and then what would be the right way for them to start exploring how they can use the Turbine system?
Yeah, absolutely. So some of the early pilots we're involved with on the user side are big insurance companies and financial services companies. And a nugget one of them gave me is, just the idea that we save them so much time and heavy lifting and going to create accounts and logins and conversions of things from, all these individual states and cities. And that particular application involves counting vehicles, vehicle velocities, people running traffic lights, and so on. And we are the first system to put all that in one place, as far as we know. So we're going to continue to acquire data like that from all these public agencies and expand that, in theory, forever. So there are a lot of users in financial services, especially hedge funds, property and casualty companies, who are starting to realize that this is available. They're a one-stop shop. The other one that is so fascinating and leads to that cool stuff in the cell tower, there's a lot of companies right now working on autonomous vehicle technology, ranging from stuff on the ground to stuff in the sky, you name it. And they're starting to realize that, much like what happened with big planes, you can't just do everything in the cockpit. Eventually, you're going to have something running the show that's not in the plane. And that, of course, became air traffic control. They can now use our system to get data from the infrastructure that the vehicles are moving through, which is a big augmentation to their onboard sensors and GPS readings, like, road surface conditions, maybe really interesting things like microclimatological information. It's all in there, and it just never stops growing. Ultimately, since you gave us all the way out to 24 months, pretty soon we will see commercial entities who are interested in their data going to other places and in particular monetizing it, coming onto the platform. One other thing for completeness I'd like to mention, we are really big on STEM, science, technology, engineering, and mathematics. And we started testing our system last year with mostly grad students and so on at universities. We actually made our whole data trove available to students and said, hey, we're going to give you free access to this, and we'd like you to come up with interesting applications. We actually offered scholarship money. It worked out really well. We had 3,000 students from 120 countries join this effort, and they did come up with some very ingenious applications for all of this public agency data. We decided that for all time, our data trove would be free to bona fide universities and research organizations, as long as they're not for profit, and that we'd also like them to put their data in our system, so it's a nice joint relationship.
Okay, that's an incredible resource. Well, David, I'm certainly going to reach out to you also in 24 months and get the update. I mean, I think this is going to be a long journey, and this is really one of the most important companies that I've come across. I mean, we research really, thousands of companies, and most of them are doing important things, but things that are fairly narrowly focused on solving a spot problem. And what you're doing really here is building an infrastructure that, if you succeed, and I certainly hope you do, will really revolutionize how people are able to utilize IoT data. So
I've been really reticent to opportunistically do anything that has to do directly with COVID, because I keep thinking, oh, come on, it's obnoxious. But apparently everybody's trying to capitalize on COVID. So then I realized there's something we could do that would actually be helpful, which is, I don't know about other countries, but in the United States, when they have these briefings from the president or governors or mayors of cities, they're not doing it as much now, but in the beginning, they talked a lot about things like ventilators and testing equipment. So these are, a ventilator is a really fancy piece of equipment. They cost as much as a car. They're just bristling with processors. And, these are the things that control, they put a tube in you, and they basically very sensitively monitoring what's happening with your lungs and your heart and all that, and then deciding how to augment your breathing. So it has a simple name of ventilator, but they're actually really very sophisticated hardware. There just seem to continually be these, like, where are all the ventilators? How many does this hospital have? How many does this city have? So we're talking to some other people in the IoT world, and we said, because these are fancy machines, they must have some kind of connectivity that are used for maintenance or something. So we went off and did some research. I put one of my cool students on it, my grads, and I said, anyway, he came back with this pretty elaborate spreadsheet of 25 companies who make these ventilators from all over the world, including China. And it does not include, the president compelling Ford to make ventilators and showboating things like that. This is companies who say, we make ventilators for a living. It's, Siemens and Hitachi and all those kind of guys. So we realized, well, aren't these essentially IoT devices? So it's like a car. If it's a newer one, and we have all the model numbers and everything and their capabilities, the connectivity is there. If it's an older one, you would have to attach something to it to make it a connected device. Well, that's what you do in a car. You put an OBD2 device in the port. It's on all the cars, and now it can talk, to a connectivity system. So we just recently, we came up with a sort of a document that describes how you would treat these machines, these medical devices, as IoT devices. And you could immediately know where they all were. And you would also know their operational condition, like, are they under maintenance? Are they sitting off in a warehouse? And there's ways to get that heartbeat from them, even if they're switched off, just like you can with other machines. Or are they sitting in a hospital connected to a patient? Then put that on a map. We wrote a white paper on it. And the cool part is it has zero to do with patient data. Like, we don't even care who the patients are. It doesn't have any of the regulatory compliance stuff for health data. It's just the machines. And this is based on what I said earlier in the interview. That's the same with cars, right? We don't really care about whose car it is. We just care about the data that car generates and where is that car on the earth. So anyway, that was long-winded, but it turns out there is a thing that IoT can do in COVID that could be really, really helpful. In the US, we've just started to approach the Federal Emergency Management Administration, FEMA, to see if they'd be interested in that. And then we just kind of rope together all the players that would need to cooperate, because we don't see the pandemic going away in a month,
Yeah, I mean, even in the longer term, I could see this being a huge resource. Even when we don't have a pandemic, just knowing where there is medical equipment in case there's an emergency, or even during normal times, right? I imagine there's still a lot of hospitals, especially in more developing regions, that are just under-resourced, right? And
absolutely. And there is one huge caveat, capital C, which is, in researching this, we found that a lot of hospitals hoard these machines and they don't want to tell people that they have them in reserve. So we realized it would take something like, at least in the US, it would take the federal government to just say, no, this is the law. You have to, but as you probably read and seen, these things are moving pretty fast. So 2 years ago, this happened in the big long haul shipping industry, where the federal government, through the Department of Transportation, mandated that all large trucks, the kind that drive big rigs with the big trailers, right, that they have to have an onboard logging device that captures all this data about what the truck is doing. It started with the idea of just monitoring, making sure the drivers don't drive for 16 hours on amphetamines and stuff, but which is why it started. But it kind of, once it became law, it just turned into this thing that, wow, we can know all this stuff about what's happening out there. So the federal government, just through a single pen stroke, got all these big rigs connected. It happened really fast. And if you don't have one of these devices, you get a fine. We said, well, they did that. Why can't we have them do the same thing for these medical devices? So what's really cool is, if that goes anywhere, I mean, our system is just totally ready to do it. I mean, it's really just ready to do it, but somebody's got to interface the machines into it. I've heard a lot of IoT discussions for COVID-related things, but they're always little things, like the fingertip oxygen monitor or something, and this is an industrial class use of IoT for real benefit. So I hope it goes somewhere. I mean, it's going to be out of my hands very soon and in the hands of federal people, but I think it's really an interesting concept. Well, anyway, this has been great. Good to catch up, kind of literally. And obviously, stay healthy and safe yourself out there.
Yeah, you as well, David. Well, have a good rest of your evening, and I'll look forward to our next conversation.
All right. Take care.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT ONE HQ, and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@iot1.com.